Hi, good day everyone. So today we are going to learn a few tips on how to find your LCM fast. Now, if the numbers we are finding the LCM of are prime numbers only, we simply multiply the prime numbers and the LCM can be found. So, for example, because I always like to do examples, right? Let's just say I need to find the LCM of 2, 3. 2 and 3. Now, 2 and 3 are both prime numbers, and if we forget what a prime number is a number that is divisible by itself and 1 only. So the only numbers that could go into 2 is 1 and 2, and the only numbers that could go into 3 is 1 and 3. Right? Because these two are both prime numbers, the LCM would be equal to 2 multiplied by 3, which would be equal to 6. Right? That's example 1. Let's do a next example. Example 2. If I have to find the LCM of 7 and 13, right? 7 and 13 are both prime numbers, right? So to find the LCM, I'll have to multiply 7 by 13. 7 3 is 21, 1 7 7 8 9, so it'll be 91. And that is how you would find the LCM of numbers that are only prime numbers. Okay, next option or next example would be if we have to find the you have to find the LCM of numbers where the smaller number can go into the larger number exactly, meaning if you divide them you will have no remainder. The LCM will be the larger number. So let's give an example. Let's just see. We have to find the LCM of 2 and 10. We first ask ourselves, can 2 go into 10? Yes, 2 could go into 10 5 times. Right, so because 2 could go into 10, therefore my LCM will be my larger number, which is 10. If I have to find the LCM of 7 and 21, 7 could go into 21, yes. So because 7 could go into 21, my LCM is going to be the larger number, which is equals to 21. Right, let's say 2 and 8. LCM of 2 and 8, because 2 could go into 8, my LCM was going to be 8. Right, and that is how you can find your LCM of numbers where the smaller number could go into the larger number exactly. Right, now if the numbers that we get does not follow the first way, which are both prime numbers, and the second way, which are they are divisible by each other, therefore the larger number would be your LCM. Your third option would be 2. Right, so if this one that we're doing, if you have to find the LCM, right, the numbers have the numbers are not prime numbers and cannot go into each other, we are going to do the long method. And the long method is, for example, let's say I need to find the LCM of 215 and let's say 215 and 3. I have to find the LCM of that. So first off, I'm going to put 2, 3, and 15. Now, the numbers that are going outside here that we're dividing are going to only be prime numbers. So let's start. The smallest prime number is 2, then it's 3, then it's 5, then it's 7, it's not 8, not 9, not 10, then it's 11, then it's 13, and so forth, right? So we're going to ask, what is the smallest prime number, right, which is 2. Can 2 go into any of these numbers, at least one of them, without leaving a remainder? Yes, 2 could go into 2. So you're going to use 2 here. So you say 2 into 2, 1. And then you're going to say 2 into 3. Because it cannot, you're going to bring it down. You're not going to say 2 into 3 and whatever is the remainder. No, we're just going to bring it down. 2 into 15 cannot, so you bring down 15. Right? Then you ask, can 2 go into any of these numbers? It cannot, so we're finished with 2. We're going on to the next prime number, which is 3. Can 3 go into any of these numbers? Yes. 3 could actually go into both of them. So you say 3 into 1, cannot, bring it down. 3 into 3, 1. And 3 into 15, 5. Right? Then you ask yourself, well, can 3 go into any of these numbers? No. Cross it off. Then you go to the next prime number, which in this case is 5. You ask if 5 could go into any of these numbers. Yes, 5 could go into 5. So 5 into 1 cannot, bring it down. 5 into 1 cannot, bring it down. 5 into 5 is 1. Once you get this 1, 1, 1 at the end, our LCM would be equal to, you multiply these numbers outside. That's 2 times 3 times 5. 2 3s are 6, 6 5s are 30, and you put 30 here. And that is how you would find the LCM of numbers that don't have anything in common. Right? And that is how you would find the LCM of numbers, whether you need to find it when the denominators are not the same and you're adding or subtracting, or the question just says to find the LCM. This is how you will do it.